They started dual nature in my class. So my focus look.
Last year, easy chapter, but very boring chapter. Because I mean, if you don't learn this chapter, then next one it says atoms and nuclear will come everything. But the most important thing is nuclear. We have two derivations. Yeah, right. How to? Hey, when are your holidays starting from? 11 to 21 holidays. 20 to
20.
No, till 18.
21st college open. 21st is Saturday. Monday exam.
18 for you. What? No, you guys have exam in between.
No, exam South Board.
Yeah.
24.
Bio.
So when are your holidays starting?
Yeah, but
Come on, so- Hey, when holidays starting for you?
Huh?
Holidays.
11.
Same.
I don't know.
You guys have 10 days holidays or 9 days holidays?
9.
11 to 21st is how many days?
No.
Maths.
Bio.
College reopen from Monday. College. Which was maths.
What will you guys do to go that day? Pick up the holiday?
Saturday. No one will. Attendance.
I have no idea. As far as I know, they said it will be somewhere around 31st or 1st. Diwali.
Right between
What exam is the number?
This one I'm not able to understand. Am I wrong or the example are wrong? I mean, I can't.
After that's not the holiday.
That's why they are the different days.
Yeah. They are from October end.
No.
October is
Chemistry,
31st
English,
only.
bio.
This one, when I searched Diwali for this year, I think it was around 31st.
Huh?
31st.
Yeah, 2024.
Still, even math is not first.
What happened?
2023 would have done.
No, last year it was on KK's birthday, so November somewhere. Last year. Yeah,
What?
30th was 14th. Yeah. But I think this year is 31st, I'm not sure. 31st only. Then what will you guys do? 31st,
Yeah.
Alex, check 31st, what exam you have?
So take.
Check.
Yeah.
You have. Huh? See, guys, you have a holiday there. Hey, listen. 30th, you guys have something called as Logic, Geography, or Education, which none of you guys are taking. Yeah, whatever. 29th, it's math for the South Board, for North Board. Okay, fine. So 29th, these people have math. That gets over the day. And 4th is when you guys have your language. So from 29th to 4th, you guys have holiday. That's Diwali. Because see, 29th is Tuesday. 4th is Friday.
We can't enjoy holidays also.
Who will enjoy holidays? What are you? Third side of enjoying holidays, it seems.
No.
We are watching, huh? What?
Scooby. No, Scooby is there. First.
Alright.
Animals can hear.
Scooby is the veteran. That's the OG actually. He said it is. It comes in point is almost a sentence.
5 times.
Yeah. That dog is actually veteran. It comes with mind your own business. Does it work? Keep moving.
Jax is also there.
Okay, let's start with aldehydes, ketones, carboxylic acid. This is heading as aldehydes and ketones because we will solve carboxylic acid once we are done with both of them. Same thing we're learning also. Learn aldehydes and ketones first and then the carboxylic acid. Again, the name says aldehydes and ketones, but the way we will be solving it is almost using the same type of equation, nothing, absolutely almost no differences. Preparation is very important in terms of for 3 marker or 5 markers, 5 marker in the sense 3, 1, 1. The reason is because a lot of named reactions will be asked in this chapter. That's the complete thing. Rosenman reaction, Stevenson's reaction, whatever happens when you guys come across a name, don't skip it. Okay. Here you will be learning a lot of practical examples. Do you guys remember something called as EDTA? We solved ethylene, diamine, trimethyl acetate. Remember we're solving this? So the application of that will be used in blood test. Okay, that's an example. So similarly, in this chapter, we'll see a lot of concept which is being used in daily lives. Okay. One more thing. Do you guys know the exact, I mean, the reason I didn't tell this is because once I continue with the chapter, I'll try to, blitz this later. Do you know as to what is the main use of human fat? Have you thought about it? No. That is when you are alive. No, serious. But there are a lot of people who go and get this treatment to cut off the fat from the body. What is the called? Lapro. Can I go? There's something, I forgot the name. Yeah. Okay, that's the name. So basically, they tend to remove the excess fat from the body. Okay. People never realize what's the main use of it. Today's class will realize what's the main use of it. Okay. Then I'll give you a reference as to where you guys might have seen it before. But human fat has a lot of use. I mean, when it comes to the body also. But the survivor. Yeah, when you take it out, they make soaps. So yeah, no, that's
Human fat.
yeah. They make soaps, and that's the best soap that you can get. No, seriously. That's the example. Okay, fine. I'll talk about this bridge later. But the example is, have you seen these hillside? There'll be a river flowing, and there'll be a hill basically. All these people in the village, they tend to go and wash clothes, or wash clothes in only one part of the river. If you're wondering as to why only that part of the river, the answer which they give here is, if you want the water in this part of the river seems to no. River means flow. By one point, they tell that the clothes get washed much better. Okay, people never realize this concept for a long time. Then when they actually research, they realize that let's say there's a flowing river here, and this part is the main point for washing the clothes and all those things. So that's the same place, hilltop there. They used to burn dead bodies. Now what used to happen here is, this river used to flow. I mean, regular. It's a tributary kind of thing. Okay, they used to burn bodies here, and obviously this river used to start where the direction of the river was like this. Getting it? It used to flow through it. So what they used to tell was, obviously, how do they burn bodies? Body, and below that there'll be layers of wood and fire. That's how it is. So when the fire and the wood meet, what happens? Charcoal or ash. All those things have been formed. So when the river flows, when the water flows through the specific thing, it carries three things. One is the water. One is the ash. The other one is, when you burn the human body there, the fat drips. Correct? I mean, you know that when the skin burns, the fat drips. I mean, there's actual fat.
So,
Yeah, no, it drips. That's what. Liquid, becomes liquid. It drips. Huh? Correct. Almost like wax, but it's more modern in nature. Okay. Wax, but one layer before it. That's somewhat other. Okay. So when the river flows, it carries the fat of human body, those ashes and all these things. It forms this commonality is called as rime. Okay. That rime flows through the river like this, hits this point here. Okay, and that is a very, very useful cleansing agent. But the thing as it works. So people never used to realize how is only this part of the water body making the clothes so clean, and they could literally see the dust going off. They use the same concept in the movie Fight Club. Have you guys watched it? If you guys have not watched it, go watch the movie Fight Club. They'll go and steal fat from the center, and they make what? They make soaps. He'll tell in a scene that these soaps sell for $20. And $20 of soap is like expensive, because you'll see a small gesture where one woman comes and talks to him telling, the soap is really good, what do you use it? He'll be like, love. Okay, that's all the things that are bullshit, but this is the actual concept. Okay, the same thing you will see in terms of aldehydes, ketones, all these things. Obviously we don't use the rime to form, but they are again agents which are used to cleaning things. But that's how it works. Chemistry is actually used in everyday life. It's just that people should know how to apply things. People hate chemistry, but a lot of it's very useful. Again, as I told you, EDTA, almost all the tests you guys have, when you guys go to the hospital, almost all the tests, what do they use? They use some kind of chemical only. Chemistry is very important. Okay, so if you by chance take up some kind of pharmacy or next year, you'll get to know better about it. Is it a good course? I don't know. So aldehydes and ketones. Now, obviously, we start off with the concept called as carbonyl group. Understand, when you're trying to learn this concept called as aldehydes or ketones, learn the carbonyl group better, because without carbonyl group, both aldehydes or ketones will not exist. So carbonyl group, this is the general, don't write it. This is the general representation. So I take this group, I'll keep it play. I'll take this group out of the remaining two bonds out there. I'll add H here to one of the bonds. Okay. Now, if I add H here, okay, or instead of H, if I add an alkyl group, anything is fine. Okay, HCHO or RTHO. Obviously, there's nothing here means by default what come and say H will come and sit there. I'll ignore that. If there is only one R attached to the carbonyl group, just one R, this concept will be called as aldehyde. Simple. But for the same carbonyl group, in both the bonds, if there are two R's coming and sitting, then it will be called as ketone. So if you see the difference between both of them, the main reason as to why I didn't add anything is because by default H will go and sit here. If this H gets replaced by another alkyl group called as R, then this concept will be called as ketone. But both 1 and 2 are nothing but types of carbonyl group, where what matters is whatever is there on the remaining two bonds. So I'll get how it works. 2 R's, ketone, 1 R, 1 H. Again, don't let us 1 R, 1 H. Just let us 1 R is there, then it's for the aldehyde. Both are alkyl group, then it's for the ketone. Note it. No? Okay. That's the reason as to why I'm supposed to learn both of them simultaneously.
So carbon and chloride is positive.
Yeah.
Then there's no H in that.
Okay. What is that?
COCl2.
Oh, there are two chlorines.
The R will get replaced by chlorine.
Yeah, that's it. See, yeah, that's not it's phosphine is more like an exception. Getting it. So how it works here is see COCl2 it is 4 bonds, 2 bonds with oxygen, remaining 2 bonds with that, and you both substitution reaction. Like CCl4 it happens. How does CCl4 get formed? Hydrogen keeps on getting replaced and forms chlorination. Keeps on getting replaced with chlorines. So we'll have 2 H, aldehyde. I replace both the H with chlorine during substitution reaction. I get phosphorus. That's a preparation. Makes your work much simpler. Nice. The good.
We write a general class to write exam.
So we can just do one class. Because organic only.
Except
Then you
Only that class.
how do you think carboxylic acid is formed? Carboxylic acid is what? C double bond O, single bond OH. So one side there will be R, one more side there will be OH. That's all. But end of the day, this also is dependent on carbonyl group. Okay. Don't try it at this point of time because anyways we'll do carboxylic acid later once we're done with both these things. Okay. But aldehyde and ketones are the most important ones. Today we'll do preparation, one part of it, and tomorrow's class we'll do the preparation as well as the components. Right? I think I'll take this week to finish up. Hopefully. Next, preparation from alcohols. Now we'll take
Fraction of value is from.
from alcohols. Under that first one, by the oxidation of alcohols. By the oxidation of alcohols. Okay, I'll write 2 reactions. The first reaction will be for alcohol, wait, aldehyde, second one will be for ketone. Simple, right, wait for a second. I take RCH2OH. Alcohol, right? Can we go a little deeper and try to understand? Can we call this as a primary alcohol? Reason because to the main carbon, how many alkyl? 1. So this is nothing but primary in nature. Okay. Heading says what? By oxidation. I'll just write O. I'm supposed to write O2. Now please get the difference. If I write O2, I can also use the word combustion. Okay. Combustion actually means in presence of like literally oxygen. Here, when we're trying to use oxidation, 90% of the times it will be nascent oxygen. Remember this. So whenever I use the word nascent, I'm supposed to write that thing in brackets. So write brackets, nascent oxygen. Again, famous catalyst, KMnO4. You learn this in which chapter? Yeah, perfect. Okay. The most used oxidizing agent. They usually tell this KMnO4 in presence of H2SO4, but if you just write KMNO4, there's a video marks, no worries. Okay. Now, obviously, observe only this part, and there is a hint here. Take off water from it. Okay, take off water. How do you just represent water? H2O. But there's a logic here. There are two ways to take off water. One is, look at the box part there. If I remove that, it's nothing but I'm taking off water. But there is absolutely zero connection established between this carbon and this hydrogen. So we try to avoid that method. Okay. Where else can we take off water from? Listen up. Very simple. This part says OH. To make this water, what extra do I need? One more H. And that H, it will borrow from the next carbon. Okay, which has CH2, it will take one H. This one H from here, OH from here, forms what? Water. Now, after taking off the water, R remains as it is. Careful. C remains as it is. Out of two hydrogens, you use up how many? One. How many is left? One. Okay. Till now, did you look at nation of oxygen? Not yet. Only the main compound is what we're trying to look at. Fine. Ignore. We are ignored this right now. This goes and sits next to hydrogen. If you ask me why, before this reaction took place, to carbon, how many things were attached? Two things were attached. What were they? H and H. Correct. There were two bonds there, out of which one bond moved away. Getting it? There was a vacancy here. And who is there to fill up that vacancy? What we are trying to add. What are we trying to add? Oh. RCHO is called as aldehyde. It out here? No, wait. I used a primary alcohol to get aldehyde. It out there. Now, I use secondary. Agree here? Secondary meaning how many alkyl groups? 2. Think and tell me, this carbon needs how many more bonds to get satisfied? Huh? I want to know it also. So, is this correct? Correct, huh? Because one with hydrogen, one with OH. That's how it works. Fine. What happened here? This H got replaced with R. Isn't that the same thing we're doing here? There was a H here. H gets replaced with R. It becomes a ketone. Getting it? So, there was CH2OH. It became CHOH. The extra H got replaced with one R. And this becomes secondary what? Alcohol. Again, we are trying to perform combustion or oxidation. Oxidation meaning you write O in brackets. Again, the most famous oxidizing agent is KMNO4 in presence of obviously concentrated. You write that. Okay. Now what's going to happen? The same old logic. I'm supposed to remove what from here? Water from here. Now, if I remove water, obviously don't you think OH comes out? To satisfy OH, to make water, we need what else? H. It lasts for the carbon. Carbon in this case has how many hydrogens? One. It will donate. Because formation of water is also important. This H and this OH come out, right? And form what? Water. Now, whatever is remaining, we'll try to copy that. Two R's were remaining. Both of them are attached to how many carbons? One carbon. Now, whatever was attached next to carbon, everything got used up. To form what? To form water. Now, think only from this carbon perspective. What's the logic? Wherever carbon goes, how many bonds follow? 4 bonds follow. Out of 4 bonds, how many are done? 2. How many more required? 2 more required. Wherever 2 bonds follow, what? Pathological short works. Now, this is ketone. But the main difference between aldehyde and ketone here is, I didn't write the structural formula here. I just do the molecular formula. Better way of writing here is, draw it off. CC. R, C, double bond O, single bond H. Getting it? This is to just tell that wherever oxygen is going, 2 bonds are being followed. Same concept here also. Okay? If you draw it, sense of clarity, not only for your teacher, but you guys also. Again, what I've been telling, wherever there's H in aldehyde, it gets replaced with what? R. Same. Okay? Name has aldehyde, ketone. Same concept, but the types of alcohol which we use were different. That's all. Tertiary won't happen because there's nothing here. Water can't be found. Okay? Guys, got that thing here? Tertiary won't happen because this H will get vanished there. There's nothing to get attached there. Write the names. First one is aldehyde. Second one is ketone. Don't look at the board. Right. If you go wrong, you don't look at the board. Hint is you start off with the primary alcohol for aldehyde, secondary alcohol for ketone. That's it. And please mention the primary alcohol below that and secondary alcohol in the ketone reaction. Done?
Give an example of.
Because what maximum can you change? You will make the RS CH. None? Not here. Next heading. So this is from alcohols, that's done. Next heading. By catalytic dehydrogenation of alcohols. By catalytic dehydrogenation of so hydrogen means what? This one you don't know. Dehydrogenation of alcohols. Hydration. You feel dehydrogenated or dehydrated? You feel what? What? Underline the word catalytic dehydrogenation. Without the catalyst, these reactions will not take place. But if you see what's the last word in the heading? Using what? Alcohols. Again, you tell me when I'm trying to get aldehyde on the right hand side, what alcohol should I use? Primary. So concept is same thing with ketone. Secondary. I'll start with the primary one. So it becomes R CH2OH. This is the primary alcohol. And here, since it says catalytic dehydrogenation, I'm supposed to use copper or Ag in 573 Kelvin. Choose one. I will always choose copper. I'm not a big fan of this. Okay, copper 573. Please mark this up. Most asked reaction this is. Now wait. This is primary alcohol. We'll talk about this. But the question says, the heading says dehydrogenation. Dehydrogenation meaning removal of hydrogen. In other language, removal of H2. A good thing. Easy way to teach you is cut off H2. That's the easy way to teach you, but that's not how it works. Please understand. Look at the structure here. What is the one which is outside? OH. No. In OH, I'll cut off one hydrogen. You tell me out of H2, if I used up one, I need one more. And that will be provided by this one. Okay. So out of 2H, one gets used up. After getting used up, it looks like R remains as it is, C remains as it is. Out of 2H, one got used up. How many remaining? One. Along with what is there? O. What is this? RCHO. Now what's going to happen here is, if you learn it this way, a lot of college teach that there's nothing wrong. What they tell you is, cut off the next two, RCO. RCOH is remaining they tell. Then they'll be like, flip this, it becomes RCHO is what they tell. Agree. But let's draw secondary alcohol. Secondary alcohol looks like this. CHOH. Cut off the H2 and C. How will you come? Methodological how it works. So here there's no H2 only present here. So you can't cut the thing directly there. So always understand, you start off from whatever is there available to me at the extremes outside. So same, see, apply the same rule here. Extreme we see OH, fine. Out of in OH, we cut off how many H? One. We need one more. Take this off. Again, R, C, and O is remaining. That's nothing but ketone. But like how it works, always start from the outside. There's nothing wrong in this. They tell you to flip it. You can't make OH minus as HO minus. Does it make sense? Zero sense. But they'll tell you that. Don't follow that. Okay? Remember this. It's always the outermost one. Outermost halogen which helps in the breaking apart. RCHO. But again, as I told you, try to draw it. Gives you much more clarity. RCHO. What? Double bond O, single bond H. Plus what? That's important. But so it's important only for ways to learn here, but exam is fine. This is what alcohol? Secondary alcohol. This again, catalyst will be the same. Copper. What temperature? 573 Kelvin. Remember the other day I told you one hint for writing temperatures. I told you write everything in terms of odd numbers only. In 90% of the time, ends with 3 only. I told you the other day, morning. Hey, morning I told you. 573, 273, 973, 773. So only few things are 753. You will never find an even number. Almost all the odd numbers, the temperatures will end with 3 only. So 73, but there are few things which end with 53 also. But if you are choosing 3 digits, which you will, 273 is a Kelvin conversion. This you guys know, Kelvin to Celsius and all those things. That is 273. Look at all other things. 5, 9, 7, 7, all these things. By chance, you guys get stuck in your exam once. These are the numbers. End with either 73 or 53. First number, you think whatever comes to mind. Okay. 973, 773, very rarely used, but used. Okay. Majority of the time, it's either 573 or 473, very less times, but 573 is the majority of the times it's being used. But this state works almost every time. 73, 73. But all 3 numbers will be even, will be odd numbers. Look at from the side, 357. Every other thing, 357, 379, all these things will be used. These numbers will be repeated. Keep this in mind. Okay. Use this. It's important. Now what has to be done? Wait. Removal of H2. We start from the outermost thing. Outermost thing says OH, out of which I take off 1 H. 1 more is required from here. After take it off, both the R's remain as it is, attached to 1 carbon. Ignore that. So look at this. This carbon needs how many more bonds? 2 more bonds. What is remaining there? Oxygen. This is called as plus. So in the first thing, water is the byproduct. Second thing, it's a gas. Okay. An observation can be asked here. Hydrogen always burns with the what sound? Pop sound. The identity is the 570. Psycho. Yeah. Jim Silva, 6 o'clock in the morning. 8:30 wake up. Sleep at 9:30. Best it is. You can't do that.
But actually,
I'm actually telling you, if you can't read late night, sleep at 9:30 and have a sleep. But if you sleep at 9:30,
come on at 9:30.
that was sleep at 8 o'clock. Yeah, he eats at 6. You're working somewhere.
But
Kinder
by 9.
Where are you working? 9 o'clock to go home.
Yeah.
I go faster. Actually, what Marshall?
He's describing himself. No.
Keep something again. Come on.
Yeah, sir. Yesterday at 9:15.
One extra
Tolerance period is one work.
telling. Once you start with the name reaction, very easier, but too much. Why should you know everything?
I tell you, Aldol condensation.
Aldol condensation, cross Aldol. Those are all.
Again, the iodine test which you know will undergo. And
Wolf-Kishner, Gatterman coach.
and that Canazaro.
Canizaro. Gatterman coach is repeated most of the times. You see.
If any benzene thing is there, it's Canazaro.
You don't have the
We
definition
finished
of
chemistry,
carboxylic
no?
No, that is a different concept. So basic, the chapter is aldehydes and carboxylic acid. When we learn aldehyde, we can also learn ketones. That's why they named as aldehydes, ketones, 1, and carboxylic acid. So it's like part A and part B. Part A will learn 2 things.
That day he
Part B
only
is
saw-
only carboxylic acid. It's like, remember we learned alcohol
Don't
from ethers.
finish.
Alcohol from the same thing.
Ethers on small part.
Same thing. But carbon is the
You
important
don't
part.
finish the whole
Compared to this
subject.
also, I think that one is important. But it's under it.
Yeah.
Same like alcohol phenol. We learned alcohol. We learned R. They learned benzene. That's the became phenol.
Part of textbook is finished.
No. Next today.
That's eating effect of current you have to do.
One day.
So dynamo transformer alone.
Madale.
Important, huh? Important. Yeah.
You do for the sake of doing it. Don't expect anything from it. Okay? You do it.
First, you see that trigonometry chart is more important.
You need that.
You need that, no?
ASTC.
That's important.
Questions they want to ask.
If they ask you the last one, you ask question. 5 by 4 is the answer. You can't talk. Maths is very easy to learn, but the moment you start solving it, it becomes more difficult.
Now, what to do for math?
It's fine. What? You can't even talk of maths, right? It's the
25 is good.
Didn't start math. What's wrong with you?
30 if you're able to do.
This is for you, I think.
What math? Math, challa, math. Next. From carboxylic acid.
I don't really function. Oh, that was last year.
When did I? So I did then.
You didn't know what he meant.
Okay.
Oh. From carboxylic acid. Carboxylic. But it takes. Don't talk about Pentlow, that's fine.
So what is this?
Oxys.
That is
Oh, you've seen. His brother saying, well, I think like there's no.
So you continue, sir.
Don't think out of the box, think like the limits. From carboxylic acid, another first one. Why you're laughing?
I'm not.
By passing vapors of
You should have last time. It's more expensive.
that time. No, what how much that? No, that time was no.
The passing?
Vapors of small. Telling you not.
Actually,
That's me. No.
You can buy some shops and
the tell.
Vapors of carboxylic acid over manganese oxide. Manganese oxide. What do you want? Manganese oxide, right? Do you know what is formic acid? Carboxylic single bond OH, you know. Here, just put on H. The most basic carboxylic acid will be called as formic acid. Put out here. So we get it as HCOOH. See guys, this is the molecular way of writing it or representing it. This is the structural way. I am always comfortable with the structural way itself. I tell you why. Now what's going to happen here is we take 2 in number, okay, but don't write that number. Draw it. HCOOH. Read the question right now. In presence of what oxide? Manganese oxide. MnO has to be a temperature. Tell one. Works. Seriously, that's the answer. Now, look at the thing carefully. Instead of me writing 2, the reason I'll write this in terms of molecular way also. Instead of writing 2, the reason I wrote it twice is because, focus. Look at, both of them are close to each other, no? This H, when it comes out with a what sign? Plus sign. Which means it needs somebody who's negative. Obviously, it won't have with the same person. Some other things required. Who do you think is the most negative part here? both of them react to form what? Water. Okay, we'll talk about that a little later. So can I tell here? This happened? Agree? Now, I have a small doubt here. Between this O and H, there will be a bond. You know that, no? So I'll put a small bond that I can show. The thing here is, whatever I've watched, that's a famous gas. What is it? CO2, also called as carbon dioxide. So I'm going to ask me, sir, should we take CO2 from both the places? No. Why? Because just imagine you took off CO2 from here also. In the first part, once you took off that CO2, what is remaining? H is remaining. Here, what is remaining? H only is remaining. We get H2, which is not at all useful because what is the chapter's name? Aldehyde. We want one aldehyde. So what you guys will do here is you will use both the compounds to take off water. Okay. Then out of two, use only one to take off CO2. Getting it? You use both to take off water. You use one to take CO2. Now I tell you the main reason. The reason as to why you're using two compounds to take off water is because you guys know that this H and this OH minus won't come outside because they belong to the same compound. Getting it? So you require the assistance of somebody else. Therefore, you put H plus as well as OH minus for this. But CO2 here, it can by itself it can come outside as CO2. It does not require any help from the other side. Need out here? No. Now, after CO2 came outside, after water came outside, in the first part, what all is remaining? You like that? H is remaining, C is remaining, C, double bond O is remaining, O is remaining. Here. What? What is remaining here?
H.
This is called as what?
Carboxylic
What the fuck? Wait. Okay, wait.
No, that OH is.
OH
There's
and
no
H.
O. There's no O.
Exactly.
So it's ketone.
No, H it's aldehyde. CHO because R is. So you take an R it becomes something. In terms of molecular weight, H2O you took off. CO2 took off. In the first thing, what is remaining? HCO with what? H. Rearrange it in this case because when they are trying to merge, no, they're merged in terms of HCHO.
We have drawn a ketone there.
Where?
Here,
Carbon.
carboxylic acid plus ketone here.
Formic acid.
See, correct and do then.
So you don't do that cavity. Do carboxylic acid.
Carboxylic acid.
That is ketone one.
Which means I do it properly initially.
Yeah. I didn't tell anything, no.
I'll tell you, okay, right. I cut off the OH part here, no? I only thought H part I cut off. Wait. This complete part gets used up. Okay, no, it's correct. HC double bond O, OH and H got used up. Here, CO2 got used up. What is remaining? H is remaining. Condensate. This is HCH and aldehyde. That is obviously plus CO2 plus water. Getting it? So H and OH gets combined. CO2 comes outside. 1 second. Look at this. Water, carbon dioxide, whatever remains, combines, forms aldehyde. Correct? See again, if you ask me the expression here, I don't know because HCO and HCOH. The school said, or they'll flip it. Why is it flipping? I don't know. Okay, that's why I'm much comfortable drawing these. The structural formula compared to the molecular ones. Not that I guess how it works. However, you guys are comfortable with, do it.
One pencil. I can't remember the preparation for this.
Nobody can remember. Are you doing engineering only?
Take it.
If you give that hard, you know, it is very.
Then you tell your engineers.
The day around was telling me, the only thing you do in engineering is to tell the other not to produce.
That's what I told him also.
After doing only something.
What are you doing?
Welcome to the
Then you come back and tell.
marine engineering.
There's no interest for that. You can come and pass your.
Excellent thing.
Of random interest as towards planes.
Hey, there's no job around to that.
No,
I don't know.
It is.
Hey,
Still my one church guy is doing.
you can have job.
No, you only told.
No, Barbara is a good sport. It's a good sport, but
Yeah.
but no, that's perspective. No, for you it is the same like him. For you, it's
So you didn't even ask me why is it
The
so?
one was telling it's not the sport.
right of
In my defense, I was not wrong. But I didn't.
it was reach.
Actually, he told me to say it.
I said.
He said it.
It's also part of the plan.
I got it. Arcade game. What is this? I got it.
This is using formic acid.
What's wrong? Sir, tell him to shut his mouth.
Oh.
Tell him to attend
Kurka.
online.
Hey,
I am not telling anything. They both are talking. He's asking me to shut up.
Who both?
please.
I was talking.
When?
What? You don't. Sir, next.
And use acetic acid and formic acid get the answer. Because of how acetic acid is. C double bond no OH, right? You put the basic this one. What do you call it? It's called acetic acid. Acetic acid, I'm telling you, name R, I'm telling. It can be C2H also, no?
They can't do it.
I use the name acetic acid. So whatever it is, there's only one acetic acid.
Bad, or it becomes basic acid.
Formic acid is H. Come and get out of this. I mean, what will be the catalyst?
MN.
Hey, Mn.
I didn't tell for it.
Hey,
What am I doing?
270 is for the change of temperature, like conversion of temperature. What are you doing here? You're just trying to. This course on chemistry in Christ, take it out. It's in university.
Right? No, it seems that people have their lives in Christ.
They're uni this.
Yeah.
Yeah, crazy, no?
Half the time they'll be outside roaming.
But still, they're
But what they already did, they had to give that, no? But you did have to give that.
that's not his kind, right? You take 5 minutes, right?
You is not.
Not that later.
See.
Which one?
This,
Says JU.
yeah.
I sent one video around with someone. Bag is there. You're not there on it. Don't have it.
That's one to be on the basically only.
Oh,
You only.
BTL give
I told you now on that.
you are sent.
So I sent you.
I won't send you.
Girls when they see what phone that cool thing will open.
Properly.
What? I didn't. I didn't hear it. It's so slowly. Evolution. Constitution. Nike. Constitution completed.
Institution. What's the answer here? H2O comes off here.
CO2.
After I want shoot it.
Not finished.
Name this. What aldehyde?
Ethanol.
Ethanol.
Yeah, ethanol.
Methylene. What you got?
MDI. So what is MDI?
What is actually? Actually, it's
I used to watch this guy, perfect. Oh, you know when it used to come in the radio when like 9 years back.
I used to watch it on YouTube.
Ooh, you were number two.
He stopped, no?
Just to contact other people.
Sir, why me every
Old
time?
habits, yeah.
Evidence.
Started.
Petrol and diesel cars.
Next. By the dry distillation of by the dry distillation of
Under carboxylic only.
you understand. Last
What I didn't hear.
dry distillation.
Under carboxylic.
Say next one method of calcium salt or fatty acids. Seriously.
What is that?
Right.
Dry distillation of
Calcium salt of fatty acids. It becomes more like candle wax. That's why they use those high quality plastic bags for discarded. So if you see the movie, they go and collect it. No? It gets stuck on the bar for it. It starts drifting away. That will be mixed with the blood also, because the laparoscopy, if it is not done properly, people die. Yeah, that's a very it's a very harmful cause of what people do. A lot of people are dead. In fact, one of my cousins was
so next.
Nancy. She wanted to become thin overnight. Instead of eating the chip, we went to the hospital. It passed out overnight.
So why you're laughing?
Passed out overnight. Let me be serious. And then the serious thing.
Don't need.
She went to the hospital.
Send this guy on.
So why not calcium carbonate? What is it? See,
Guys, copy this. Now, Dave, look at this. We write HC double bond O single bond H. No, this is a regular way of writing it. What does the question say? Using carboxylic acid. So we're trying to get this answer. We're trying to use carboxylic acid. So it becomes O. Correct. So what are we taking? We're taking 2 in number. HC double bond O single bond OH. We're taking off the H2. We remove H2 and we attach it with calcium. So this is called as calcium salt of the carboxylic acid. That's all. Okay. Remember in 11th step we learned something called as sodium acetate, all those things. That's all. Calcium acetate. Okay. Now here, very simple reaction, straightforward. Take off CaCO3. Okay. So CaCO3 you take off, which means this. Listen, one calcium was there, it goes off. Gets used up. One carbon out of 2, you choose one. I choose this. O3. Agree? All those under that one form CaCO3. What and all is remaining? Tell me. In this part, what is remaining? H. C. O. Here? No. H. Right. What is actually called this? Aldehyd. HCHO. Got the reason as to why I told not to write it HCOH it is. But when you draw it, it's easy. See. In the first part, what is remaining? H. C. Wherever, how many bonds between carbon and oxygen? 2 bonds. Here, how many more? H is remaining. 1 bond. That's the answer. Don't write it, draw it. It's easier. No, nothing. Direct. Calcium acetate.
second.
Give me an answer for this. Wait, 1 second. Name the answer for me. Formic. Agree? So already catch correct CH3. Acetic acid. Okay. Now, just like this, I'll write CH3 COO. I'll take one more CH3 COO combined with calcium. Give an answer for this. Draw it. Let's see how it looks like. Obviously, what comes outside? CaCO3. Take up the CaCO3. Tell me how it looks like.
CH3 CW.
See,
Correct, sir.
CSC will be on both the sides.
No. Yeah.
Double bond, no. Yeah.
Ketone. Yeah. So basically, all the circle ones will form CaCO3. So now, guys, what is remaining? Yes, CH3CO is remaining. Careful when drawing it. You write CH3, put one bond, attach a carbon. Next to the carbon, oxygen was there, which means how many bonds? Double bond O, almost done. Come to the next part. What is remaining? CH3 on the other part. So can I tell on either sides of the carbon, R2 has been attached, which means R C double bond O R. No. This is the
You can tell propanol also.
You can't have it all.
Can you put the double bond here?
No.
For ketone, by default, it will be in the center.
You should count all.
Yeah, correct. Okay. How does one propanol look like? Okay, let's agree this is two propanol. How does one propanol look like? Don't get wrong. So, by
minimum
Yeah.
okay,
yeah, minimum 3, out of which the double bond O is always situated exactly in the middle. So, it is called as propan.
But you can also write propan.
Propan?
2 on.
Yeah, mental. How can I write 2 here? Okay, draw propan 1 more.
You can. That's what our teacher told. You can write it as propanol or propan 2 on.
Draw. Propan 1 more. Draw. So, draw propan 1 more.
I'll ask her.
You ask her anyway. You draw propan 1 more. No, actually, propan 1 is impossible. This is propan 1.
That's what she only told.
Don't tell KK.
No, bro. See, he told me a logic. Logic was correct. I told him the no. You understand the logic. After what I told you, try drawing it.
Even I understood, but what my teacher can do.
Please.
Yeah. I'll
Nadi.
ask her.
Not is chemistry teacher.
Doraemon.
Hey, Adi.
Doraemon.
This is not racist. Hey,
What is racist?
actually. Stop laughing.
Okay. Exactly.
You laughing for this? Huh? You will answer for this. This is the third type in the same way. Careful.
This no, is the same thing. Oh, number will be 2. That's all.
What am I writing here?
Same thing is right. 3 to H power. He wants to decide.
Let's get this. See, CSCO will be formed, but 2 in number. So think what can be done. So just tell me if it is an aldehyde being formed or a ketone being formed. Either true or false.
Carbon. Two numbers so both.
It's saying 9 standard 5 no classification.
All right. Both. Oh, correct.
That's power of both aldehyde and ketone. Same thing will be found 2 in number.
Same.
Yeah. For example, here CSU is
Aldehyde.
being formed.
It's correct. So,
Hey, Alex. What is this? Like you took CSU. That's what I'm getting from that time. Huh? 2 aldehydes.
that's what I told.
Both groups are same.
I told only aldehyde.
What is it? You tell. If both are same, then where it's CSU?
It's not
You
the
think-
same.
If both are same, it will be called ketone. How aldehyde?
That's ketone.
One of them. What is? Okay. Here, what is the? Then what is? Yeah. So here is now CaCO3. Listen up. Here you take Ca. Agree. Same thing from here. Ca. Correct. So you write 2 CaCO3. Fine. Now get one logic proper here. In this specific structure, the center carbon is this. Agree? The boxed ones are the functional groups, correct? Same thing, let's find here. In this specific structure, what's the center carbon? Agree? The remaining things are all those functional groups. So concept goes like this. You draw the central atom first, central carbon first. 1, 2, 100% you know it will be a carbonyl
Yeah.
group. Correct? Got that logic? 100% is going to be a carbonyl group. I'm telling, since 2 CaCO3 will be formed, this answer also will be 2 in number. Got that? So because of the same logic, I put the 2 here. Now, I'm supposed to fix one alkyl group here and one more alkyl group here. So since I put the number 2 here, if I write CH3, it is understood that in my final answer, I'm getting 2 of CH3, which means this got satisfied. Okay. Here, I'll by default put one H. Why? Because this C is the center. O I drew. One H is what I'm about to draw, right? That's all. Getting it? So how do you start off? You write 2 CaCO3. You write 2 here also because I'm gonna get 2 in number. You blindly draw a carbonyl group, attach both the groups here. In that case, there were 2 CH3s being used. Here I'm going to get 2 different answers, which means here is an aldehyde. In other language, when careful with the statement here, calcium acetate, okay, or calcium salt of acetic acid reacts with calcium salt of what acid? Formic acid. I'll repeat that. Calcium salt of acetic acid reacts with calcium salt of formic acid. Iodide only will be formed. Okay. Only in this case, it was a ketone. Got the logic? I just used 2 things, but 3 different combinations. Combination 1, combination 2, and we mix both of them, we still get an aldehyde.
So whenever there is formic acid and acetic acid, it will be aldehyde also.
Yeah. If it is formic acid, guys, one more hint. At least one formic acid is present. 100% answer will be aldehyde. Because formic acid does not have any extra ketone, alkyl group, no? So 100% it's only going to sit there. If H is sitting there, it is not a ketone, it's only aldehyde. So write that. Wherever formic acid is present, it is aldehyde.
What is formic acid?
You mean,
What acid?
we learn kingdom Animalia, there is that phylum.
Where formic acid is present? Wherever formic acid is present.
Aldehydes. Brown bones example. Ramen.
Falling bio to offline.
Well, ask you to contact.
Understand? No, but time was not there. Here it's I handle for them during the weekdays on Saturday. But so I have time for things. If I have no time, I have to fix that.
You know second year bio.
No, electron. No. Degree biology. Degree no BSc zoology. No, zoology biology. Zoology is academic.
That's it.
No, right. Very good. Very good. Next heading from hydrocarbons. 12. From hydrocarbons.
What?
From hydrocarbons.
What did I do?
Five. Ozonolysis. Remember this?
First year.
Of alkenes. Get the answer, let's see. Alkene. Meaning only once.
Double bond.
Ozone meaning O
Three.
of alkenes. Try, let's see. Right,
Today you were asking one bacteria there like really heat killing. Okay.
What heat killed?
Heat kill. So in heat kill, the normal cell will get killed. The genetic material won't be destroyed. I told her that. Whoever selling correct answer, she was making a statement. She didn't make it.
Why?
Simply she'll be targeting. And she changed out the question for the next guy. Then also I'm standing. She's like, next class you don't answer, I'll make you right assignment.
Relatable from first time. Your teacher.
Okay.
Or they should call it PAPO. What they should call it?
Your teachers.
Hey, some 9th and 10th all know that. No, the tall come.
Same is. Why are you?
Man of the
Our best friend. Seriously, knows you, yeah? So, like, sports captain.
So the double bond will break. Oh.
Yeah, you're
Double bond.
The 9th and 10th knows the
Again,
Yeah, every year.
last year she gave a.
Least you went on, no? How many you gave?
Now the double bond will break. Oh.
How much you got it?
Nobody asked. Randomly.
What actually?
You don't know.
Seventh and staff school girl. What's wrong with you? Shut up. That's why Mac rejected you.
Mac is not very mad. It's the first copy of this.
Shut up.
Hey, wait. Hey, listen. How do you write this analysis? First year, house. So basically the bond breaks. Instead of guys, the hint goes like this. How many carbons? 2 carbons, separate them. CH2 one side, CH2 one more side. You draw a house. Huh? Now break the bond. This, in presence of zinc, it has to happen because zinc and O form zinc oxide. Okay. Now the left hand side and the right hand side both are the same thing. No. Instead of writing it as H2CO, I write it as HCH. Got it? Totally how many have? H2 C1 complete. In this case, 2 things are found. Therefore, we put 2 in. That's all. Okay. So 2 things on each side. House. Take it up. Same. First round. First thing.
Recording.
What's that first name?
A wild boar will do that.
Huh?
Still have.
Don't see.
Control.
Copyright.
I didn't do anything.
She wants right for that.
Patent.
Wild boar.
Didn't watch it?
It's about SS.
2 HCHO.
2 are there. Hey, this is HCHO.
Black and white.
Hold.
That guy did tell me.
Very good.
Like this, same ozone.
No audio.
Audio is there, I guess. No.
Say.
I want to know why is there no audio.
You shut your mouth.
You're a cinematographer, not audio engineer. That's right. Cinematographer, she is.
I didn't do anything.
I give audio.
You go smoke.
That's so offensive, bro. Hey, there you go in that video.
Hey, I wrote O2, it's O3.
Sir, instead of blowing smoke, the video also. What?
Sir,
What I didn't listen to it. Okay, how does it work? Listen up. The double bond breaks. That side is the first thing. Draw the house. CH3, 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 CH3. Again, the zinc takes off the ZNO. The was formed here. How the property?
Oh, you understood. Understood.
That's the answer. It's the answer, guys. Last one. So, see, listen up. Both the CH3s on the extremes. Center carbon as it is. On top of the carbon, O double bond. This is. Name this? Acetone. Ketone. Propane. Or acetone.
Students use the nail polish in the one to paint.
How do you know?
Hey, very.
experience.
Thinner, Use that also. Seriously.
Huh?
Let's say on your car or a bike, paint.
But what example did he give? He didn't give that one.
What I remember then.
Diluted is for nail polish. Concentrated is for the paint.
Oh, seriously.
What are you?
How?
What's your problem?
Drink water. What is that? Acetone is faster.
It's it.
I mean, you should, there's no space here for the thing. This right, zinc and zinc oxide compounds. Well, one side I was saying, no, real degree of acid. Very good. Steve.
You went in some way and
Again, what a side effect. War markers.
for that kind of thing.
You landed
That's maybe the last. Sir, I'll call it never rain.
Yeah.
Hit the punch at least. Connect it.
But you all in class. When I sober.
Honest, that's an honest answer.
Sir, how will be talking to them? It's just a parents. Bro, you go talk to them.
Next heading, Rosenman reaction. ROS, MUND apostrophe S. Why is he laughing? I don't understand you.
Why cough syrup for everything, sir? I don't know.
Why do you laugh about it?
Area. What happened?
I'm not laughing at that.
Guys, okay, should be important, very important. 100% will be asked. H2 in presence of Lindlar's catalyst. Look this up. Palladium, Lindlar's catalyst. This is called as Lindlar's
Right,
catalyst.
right.
So she put feeding hyphen BA.
You understood.
Yeah, BS. BS.
I understood, obviously.
What is PDF file?
Listen up, guys, how it works.
I'll
Listen. There are two hydrogens, out of which one. Hey, there are two hydrogens, out of which one comes outside, reacts with chlorine to form what? HCl. Which means there's a vacancy there. CH3 and C double bond will remain as it is. In that vacancy, won't come and get filled. H will come and get filled. What is this? C double bond and single, C double bond or single bond H, and here one R is there, some kind of additions. Okay. HCl is being formed, 100% this will be off. Rosenman's reaction.
forming
Three, four.
Can't-
So both system form.
Regular acetyl chloride. Acetyl chloride. Acetaldehyde. What is acetaldehyde?
It's okay, we don't.
Two questions can be asked. Either write the Rosenmann's reaction or show the conversion of acetyl chloride to acetaldehyde, or for one marker, name Lindlar's catalyst. Palladium, PAS. Okay. Reaction is very simple. Huh? Reaction is very simple, but remembering the catalyst only is
Main
very.
reaction.
No, there's only one. Right. Done now.
How do you do those like two things react and then A is formed, then with A they react with some
Morning class.
morning class.
It is only easy. Last class, what? Last class, ABC.
yeah, which one?
So whatever. Organic chemistry. Something plus something forms A.
Yeah.
Forms B. You go step by
Sweet,
step.
they'll ask that.
You're writing, no?
Not an
In the same entrance exam, the last year also.
There are no entrance exams. Because they're not from the same state.
Oh, okay. So,
Yeah, they don't.
So there's no entrance exam.
so
But it'll be very, it's very expensive.
how much?
20.
What are you going to do in 2010? Foot truck, foot truck.
I told my mom, she's like, get a degree and do whatever you want.
This is exactly what everybody does. Then once you get a degree, you'll be like,
Get
hey,
a job and
then get married or whatever you want.
get kids and do whatever.
What did you
That's it.
What did you Get kids and do.
Relax. For the kids.
Okay. By the kid.
Okay. Tomorrow's class will do properties.
Sir, I thought it's holiday tomorrow.
Holiday. You went to holiday.
Bye-bye.